Hello and welcome back to my channel. I'm very excited to have you here because today we will be jumping into Houdini using Arnold and we are deep diving into Solaris. This will be a more introduction video style, but I'll be going into a bit of advanced stuff, how to set up AOVs, Cryptomats, imagers, all the more technical stuff, but we will be also going into creating a very beautiful render using some point instancing, light instancing, and some more advanced features, creating HDAs and stuff like that. And to top it all up, this video is being sponsored by Autodesk for showing the Arnold render engine within Houdini. And again, you will have access to everything I'm showing here today if you sign up to my Patreon source files tier. You will get this obviously and all the other previously uploaded source files as well. So now let's jump into Houdini, check out Arnold in Solaris and have some fun. Alright, so now we are looking at the final result. You can see it's quite detailed. We have all these instances of the light bulbs. We've got the ivy on it and the glow and all of that. So even though this tutorial will not be specifically on how I created this look, I will still show it to you, but the main purpose of this video is obviously Solaris and how to work with Arnold and Solaris. So heading into Houdini, I'm using 19.5403 and I'm on the latest Arnold version, 7.140. And a quick overview about Solaris. If you're familiar with Katana or Gaffer, it is a purposefully node-based system. You don't have render rough, so you have settings, but you have individual nodes which control locations and you can stack them, you can switch them out, you can create variable switches and all that fun stuff as you would be used to in Katana. And you can also see that I am not in the object context, which is where you would typically be in Houdini or the material context. We are skipping all of these actually, and we will be just working in the stage, which is the Solaris system. And also my build at the top here is set, my UI is set to Solaris as well, and this is my main working environment. I'll quickly just talk over the overview of what it is. On the left here, this is essentially my scene graph. That is everything which is currently in this Solaris context, in this USD context. And USD in general is not just a file format like Alembic or whatever, it's essentially a whole scene in one file, in one container. On the left, you will see that it all starts with a /. Beneath this, you have several different sections and you can specify them and you can name them however you feel comfortable. I kind of split them by camera, geo, lights, materials. Some of them are defaults. I think I change a couple of things, but in the end, this is a scene graph and you will find whatever is in this rendering context at this location I'm looking at. I'm looking now down here at the IPR location. That is what is contained within that location. And the further I go up, you will see that the scene graph gets smaller and smaller and you will only have small things, and then you can merge elements in and out. It's different than the default Houdini Geo object context. This is now a universal scene description. And the cool thing about all of this is you can export the USD file and bring it into a different DCC which supports USD and render that. And the really cool thing about Arnold is that you can actually render USD files directly with Arnold Kick. So you don't need to actually render it with Husk, which is Solaris's render translator. You can just transfer it right away to Kick and just render that, which is very nice. That is a broad overview. Also, this whole scene file and the whole series will be uploaded to my Patreon, so you can get access to the HDAs I created and to everything which is in here. Even my testing environment, my sandbox essentially, where I did a couple of tests, you will get all of that as well. Just sign up to my Patreon and you have full access to this and all my previous scene files. It's close to 110 different scene files now at your disposal. So as I said, this will not be fully focusing on how to create that specific look. It's mainly how you will work in Solaris to get something working. Again, this is based on my trial and error. This is how I am working. It's probably not the right way, but this works for me quite well. And I'm sure there are better ways to do things, as there are always in Houdini. This is my style of teaching. I like to be in a practical sense. I like to explain while I go and explain my thought processes. As you see here on the left, it's all split into different kind of categories. And I like to keep that like that because it's very organized and it makes just sense. At the top, you are bringing in your assets. Once they are in like camera and geo and whatnot, then you assign materials. Then you do your lighting, your camera is down here. It can also be part of assets actually. Then you have your IPR section. This is actually just basic render settings to quickly see the result in Arnold or wherever. There is no AOVs yet. And at the bottom here, this is actually a very interesting part. This is going over how to create custom AOVs. This is now, I created an HDA for this, which essentially just shows you the AOVs you have. You can enable and disable them. This is your output path and whatever. I will show you also the insides, obviously, how to set up Cryptomats, final render settings, a little bit of an override. This is just a USD export, which I said at the in the beginning. You can export this whole scene as a USD file, which this is, and then you can just launch this USD file using Arnold, Kick, or wherever, or bring it in a different DCC. And this at the bottom here is just like you render to disk, like a frame rate rendering. All right, so now let's dig in and have a look how I went about this, right? Normally my thought process is, okay, I want to create a geo. I want to instance points on it, which would be these light bulbs. And then also I have the ivy on it and all of that. So the first thing is obviously started with a very small vanilla testing bed, and then you expand it and expand it. This is how I like to work. In Solaris, you can obviously work in a sub context, and we have to do that because Solaris is just like a container. You still need to go into subs to create stuff or wherever. So Solaris has the sub create and several things you can sub import if you want. If you want to work in the object context, you can import it back in. You can quickly make modifications of an existing file or mesh using sub modify. You can create your own whole network and all of that. But I just want to create the sub create node. And then you are in your familiar environment, which is just your regular service operators. So my main intent here is to create something which I can create a font of. You will see that I have a control object which is driving this, and you will see there is like this Arnold Solaris text. If I go up again, you have this control thing here at the top, which is then actually where I have a couple of things to control everything, which makes my life a lot easier. All right, so now if I can change the text, let's just go to, I don't know, like a single letter. You will see that it gets updated and my extrusions and everything are working as they should. But I'll go through this. So I'm creating a font here, creating a connectivity attribute on this geo, and then I'm iterating over every geo. This is what this for loop is doing. So I'm remeshing this because I want to have a very nice topology. Then I'm using the quad remesher from Labs, which gives me a very nice edge flow. I'm fusing points which might just be floating around. So I'm just making sure everything works because some letters have weird shapes and they just need to be contained and merged. I'm subdividing to get a little bit more softness to this, like roundness to it. Then I'm doing my extrusions here to just get some depth to it, like that. Creating the Labs thicken node to just extrude on inside and outside at the same time. Beveling the edges to make it nice and round. And this here is actually I'm assigning a color attribute to the geo, because then in the shading I can separate the inside from the outside. It's just a shading helper for me to control things in the shading networks. Outside the for loop, this is then my lettering, and now I can just say Arnold. Voila, you have your very nice custom font, right? And the next thing now is how do you create these light bulbs in it? And they have to work procedurally, right? You don't want to place them manually. And the idea for this is to create a unique path in the inside of each letter, and then use a resample node or whatever to create a uniform point density, essentially. And again, I'm doing that in the same lettering. You will see on the right, there's another little stream. You can just move these guys down. And it's going over the same letters. You will see I'm going based off the same connectivity. But then there's a cool node. It's called Straight Skeleton 2D. It only works on planar things, right? So this is a 2D object, so that works perfect for that. And then you will see it will create these lines in between with a certain resample size and a threshold and whatever. I'm resampling it again to just create a uniform point density. I'm removing the lines. I'm fusing if there, again, some letters have weird things. So I'm just fusing all the points together. And then I'm just assigning a normal angle, which is just pointing normals forward. And that helps me to peak them, which means I can move them forward and backwards, which is what this is doing. You will see that the peak is just offsetting this. And this peaking will be used to offset the internal light bulbs. And you will see I have out points and out points for bulb. And you can see the spacing here is essentially the resampling control, and the bulb offset is just the peak control. So these are the things I'm controlling with my outside facing control options. All right, so now we are coming to the very interesting part, is how do we get a geo copied to a location, right? So we generated the points. So now in the instancer, you will see that I'm pointing the node to my out points, which are obviously these points within the lettering context here. And then you are pointing it to a primitive path where it should result the instances to, right? So I'm pointing this to geo, light, and bulbs. And this, again, whatever a primitive path is a location in your scene graph. Anything in here on the left is a primitive. So you will see I'm pointing this to geo, light, and bulbs, and geo, light, and then you've got the bulbs. And within that, you will get all the prototypes and then all the instances as well. The external sub is obviously, you can have internal ones. So if I create a brand new instancer here on the right, you can dive in and you can create points within. This will then use whatever points it has inside, or obviously there's different options for this. Geo, which is actually supposed to be instanced, and this is then my light bulb. And how that looks, it's just very simple sub stuff. So I'm just creating a sphere, scaling this upwards to create the glass shape, matching the size to a tube, and then bringing that all together, transforming this here, and then these are just instanced to the geo. And this is roughly then what the idea is. And you can instance lights, bulbs, whatever, using this instancer node. And then this is my basic lettering. Again, it's very flexible. It's procedural. You can obviously change, as I said, you can change the light bulb offset. You can change the spacing. You'll see that just updates on the fly. You can change, obviously, the name. And then it's fully procedural, as I said, and then you have a new font or a new geo here. Let's just go to the next idea. First of all, let's quickly talk about render geometry settings. And this again has Arnold and camera options. We are working obviously in comma, and within here, I just want to create some kind of overrides on my instance geo. So I'm pointing this to the prototypes in my scene graph, which is the light bulb 1 here. And then I'm just disabling Arnold, typical Arnold stuff, that the glass should not be visible and diffuse and whatnot. So this is just overrides. You can also, if you want to subdivide things, this is where you would find this, right? So you got your subdivision, iteration, displacement stuff, motion blur. So you can do all of that on the render geometry settings node, and you can wildcard this at the top, so you can affect several things or just be very specific. All right, so the next section is the IV one, and the same concept as the lettering or the bulb. You just create some geo and then you just merge it back in. And again, simple merging like this, just pipes in through, and it will just be contained in that one scene graph. And you'll now see that, oh, nice, we've got Ivy. I don't want to go into much detail about this Ivy because this is a third-party plugin, which is very handy. I use it all the time. If you want to create effects like that, it's very powerful. Sorry for the quick interruption, but if you want to get access to that Ivy plugin, I have an affiliate link below, so please consider clicking that if you want to get that MC Ivy for yourself. So now you might be wondering, I'm now in a sub-create node, but I kind of need the letters within here to be able to work, right? So you can create a lob import node in this context, and this will allow you to specify the location in the in Solaris. So we are affecting the lettering node, which is, I created this on purpose just for the sake. So I have this null with lettering, and then in the Ivy, I'm just bringing that in, and you will see this brings us in the geometry for that. Normally it's coming in as a packed USD file, which is because it's a USD format. You can unpack it, and I unpacked it twice just because it is with the bulbs and the geo. It needs just to be unpacked twice. And now we are on the poly level. We can see we have access to every attributes and everything we had before. Then the MC Ivy taming, again, this is you can buy this off Gumroad. It's very handy. I like it a lot. It has animation features as well. Essentially, you just create points where you want to start the roots of the Ivy. Then you create this object, which will essentially, it's just a VDB convert, so nothing crazy. And then it goes into the locked HDA, which you can't see through. Again, and then these some of these settings are just connected to my outside control rig to control the IV size, the density, how much leaves you want to have, a different seed, and you will see things will just change based on the seed variation. I'm not sure exactly. I just wanted to create a width attribute on the vine, so I did separate them and then pack them independently. So I've got two packed objects like this, and then I'm just merging them together. So I'm just dealing with two geos, and then once you go on the lob side again, you will see that the ivy comes in as a two object element, right? And then I can assign different shaders to the mesh or the curve, which is very handy. Curve settings, the same as the one at the top. I'm just controlling the look of the curves. And again, I'm pointing the primitive path to obviously the curves. Very simple stuff. And then material library. Yeah, it's just a material library node. Very basic again. You can just jump in here, create your Arnold shaders as you would do normally. You just created those like this. And then you can it will populate in here. You can say autofill, and then it creates you all of these things, and then you just assign them where you need them to go. Let's just view from here actually, that we can see the materials, how they are connected. So the liand shader is on this object here, which you can just drop in and then it just connects it. So we've got the geo instance, and now we want to, you cannot right now instance lights. You need to create an actual copy, but the instancer itself, you can just reference things. It will just create a copy. So one light will just be copied all over. And the same idea, you just create one single light source, and then it points to the same points, but these points are obviously the light bulb points, which we can offset, and then it just connects that to there. And then there will be, I think I can hide this, and you will see these are my lights then after the instancing. This subnet, sometimes I like to use a light mixer, sometimes not. It depends what you want to do, but the light mixer it allows you to easily just overwrite things in a very quick fashion, and you have a nice overview. And if you use a light mixer and you create a light, it will create it obviously, but it will also generate you this subnet above it. You will see that this is the cylinder light we just created. Yeah, and then the dome lights, very simple stuff. You have your base properties where you can connect your textures to, and then you have your Arnold specific settings. Light mixer, render camera, same thing. You just create a camera, point it where you want it to go, lock it, and that is that. IPR, Arnold render settings, or actually just called render settings. And then it has your standard ones, and it has obviously your Arnold specific ones. And you will see that I just connected the main camera to the camera slot here, which allows the IPR to always know the camera to render. With an Arnold, I set progressive on and all this stuff, very basic things again. I didn't want the depth of field is on by default, weirdly enough, so I just disabled that. And whenever I want to test things, this is my IPR location. And I can then just go to perspective drop down here in Solaris. You can specify your different render engines essentially, and I just want to pick Arnold now. It will translate everything, and then you can see this is now rendering live in Arnold in the Solaris Hydra viewer. And you can see you have the big dome light. You can disable those views in here if you feel like it. And yeah, you will see we've got the light bulbs illuminating. We've got the ivy in here. And yeah, the shaders again are very simple. There's nothing crazy, just a metal on the text itself, and then a green and brown for the ivy stuff. That is for the IPR. And back to Houdini. So this is now the more, I would say, tedious or technical things, which is you just need to do it once, create HDAs of that, and then reuse them all the time. And this is what I'll be doing. This AOV thing, HDA, you can obviously get that if you sign up with my Patreon. You will get this automatically. In the end, if I just allow editing of contents, we can dive in and have a quick look what this is actually doing. So it's essentially creating render variables, and then it's just connecting them. And how to create your own render variable, it needs two things to work. You need obviously the variable, the product, and the product is a collection of variables. And the render node, like in the render settings, you need to say where the render products are. So it's essentially a three-step thing, right? And if I go outside here, and you will now see that if I render again, let's just bring Arnold back in. We now have access. Oh, we need actually to go to render final. we then have access to all the AOVs in here, right? This is what you want because you want to see what's going on. You see, if I just pause this render and I create a render var like that, and let's just disconnect. Or actually, let's just go on a different stream here and render var, right? So this would be your name, and Arnold is pretty nice. You can have the internal Arnold names, and they will just set up the AOVs for you automatically, right? And this is what I'm doing in here as well. For instance, diffuse direct, you just have the name of the source, and then Arnold knows what to do with. You don't need to do any custom light path expressions. You just plug in that name, and I'll do the same right now. Render var source name diffuse direct, and then you can obviously specify the type. So this diffuse direct would be a 3-color float. You can specify your filtering. Default is box, which is fine. You can also switch it to Gaussian, set or create, move it to Gaussian, and then you have that width on 2 by default. This would be one variable. Let's just call this diffuse direct, like so. And then you create a render product, which is essentially a collection, as I said, of all the variables. And this is now looking for your render vars. And if you go down here, you will notice that on the scene graph on the left, you get now vars, and that's the one I just created, and the render product, which is the one I also just created. And the render product is looking for all these vars. So you can just plug in one here, and then this would be it. Product name is your output path. You can have it point to wherever, like a disk location. And again, this is what I'm doing in the HDA as well. So at the bottom here, I have my products, and then you will see it points actually to a location. Let me just copy that quick. So it just filled. And then the product name would go in here. And then this will, if you render this now, this would be the location for that. And again, you can specify deep output by enabling these things if you need to. Right now, I don't. And then the last puzzle piece is the render settings node again. And this is now looking for a sequence of products. It's also complaining that there's no camera right now, so I'll just drag in the render camera. And then once the render camera is in here, the error goes away. And now, as you can see, it's looking for products, and it has a drop down. So now it found automatically the one I'm looking for. And if I render now, restart render, this should now render from this render settings node. You can see now that I just have the diffuse direct. It's hard to see because it's just that single AOV, but this is how you set them up. As you can imagine, I created that a couple of times and then packaged that all up. I linked all these to the respective variables. You can toggle them on and off if you want to. But yeah, you can enable them like that. And this is then disabling the primitive count. It's just disabling that. And then you're pretty much on the go here. And then the next section is the Cryptomat, which works in a very, very similar fashion. I'm just creating a subnet again. And then there's an Arnold Cryptomat node. You just create that. Nothing else needs to be done in here. And then the same render product is looking for this crypto product, which is automatically again created. And you just connect it. Make sure you wildcard this at the end because it has these crypto materials. Product name is the same output. And that is that. For crypto, there's one more step, which is going into the render settings. And in the shaders, there's an AOV shaders. And make sure that the created Cryptomat shader is as well connected. So you will see there's this Cryptomat material, and just make sure to connect that to the AOV shaders, and then Cryptomat is set up. And you will see images is here as well, because you need to point the render settings, Arnold render settings, to a imager location as well. And images is a material library. So you just create a material library like that, hop in here, and then Arnold imager builder is this guy. Hop in here, create the images you want, connect them, that's it. And then, as I said, you just connect that to your images section here. And last but not least, you can, a pretty cool thing actually, which I just figured out, you can override the render settings either using an edit properties, or you can create another render settings node. But the cool thing is, in your scene graph on the left, you have obviously your render section at the top here, and there's a render settings node. And you will see all the current settings in the scene graph detailed with the name and the value. And what I wanted to do here, let's say I want to have for my final settings, I want to crank up the AA sample. So I can right click this and say edit property, creates a new thing here. And I can then either change the value or I can add to it. I can multiply to it. So I can say multiplied by 2. And now you will see my render settings are 8. If I say, okay, make it 3, it's now 12. And that's a pretty nice thing. And that is exactly what I'm doing with the render resolution here. I'm using the multiply that exists, and I'm just doubling my render resolution. Right now it's on 2048, and after this it's on 4096. And that is the beauty of this. And then you just hit render, make sure that the render settings node is plugged into your USD render ROP. So there's two actually, USD ROP and render ROP. Render ROP is obviously the one which will write the file to disk. And the other one, the USD ROP, will write a USD file to disk. So there's a little bit of a difference there. The USD render ROP needs some render settings. You could, if you want, override the render camera or the output image location, but the output image location is defined in the AUV, so not a big necessary thing to change here. And then all you gotta do is say render to disk, and it will, the AUVs, because we have 3 different render products, it will output 3 different things, and you will see that the location of each is obviously defined. This one goes to underscore Cryptomat, then the other product goes to underscore beauty, and the other one goes to AUVs. And as I said, if you render to disk, this will be then the result. So you will see the beauty, the AUVs, and the Cryptomat. So a quick sidestep into Nuke for a quick second. I just want to show you the process, obviously from the render to the final image. You can see I'm bringing in all 3 aspects here. So AUVs will just have the AUVs here on the left. The beauty just has the RGBA, and the Cryptomat has all the crypto data. So I'm merging them together. This is now the render. And if you look at the layer contact sheet, you will notice that you get all the fun stuff, all the data, Cryptomat and whatever, nicely laid out. I just realized I never used the Cryptomat, but it's there to use it. Then I'm reducing the noise, I'm creating some lens distortion, then I'm adding a PG bokeh, which is the depth of field, which is, it's not very visible, but there's a subtle defocus going on. It just adds a little bit of realism. Nothing too crazy. Adding some more, pretty much my defaults here, some chromatic aberration, grading it up a little just to make it a little bit more lifted. Adding the glow. The glow is for the light bulbs, and they are based on a tolerance value of intensity. If you expose down, you will see that only the light bulbs are there, and they are pretty bright, 1000 units, more or less, give or take. And then I'm glowing that up, and then that gives me the nice feel to this. And over gray, adding vignetting, adding a little bit of green, the defaults, as I said, and then obviously this will go to disk. And this is a very simple setup. And this was an introduction to Solaris, so I hope this just gave you an idea how easy it is to work in Solaris and how easy it is to create more flexible setups. And the next part of this will be a little bit more advanced. We will go into more like a shot work system where we have different render cameras and shot cameras and toggle in between those. So it's not about creating context or geometry, it's more about rendering shots and more in a lighting look dev output perspective.